we decided what we were going to talk about today? It was, right? Okay. So, the programs that you've written in this class, and maybe this is the only software you've ever written, maybe you've written other software, not quite sure, are basically toy programs. Right? How long was the last program you wrote? 25 lines? Maybe-ish? So, something like that? Which is fantastic, and it did exactly what it had to do. But if you ever got out into the real world and did real programming, would it be fair to say that program would probably be longer? Okay. And when we think about a piece of software, let's say like Microsoft Windows, which is an operating system, but it is a program, right? So it's an operating system. Is that just one program? You don't know for certain, but probably not, right? So people probably write different parts of that. So part of Windows deals with like printers, right? And another part deals with like interfaces like microphones. And another part deals with like the file system. No matter what, those are like 3 big chunks, right? So there must be different teams that work on different parts. And then at some magical point in time, a fairy shows up with a magic fairy dust and sprinkles it over all the software and what it all comes together. Woo! Yeah, there's not enough fairy dust in the world for that to happen. Okay, so something else must be going on here. And it's not like just everybody shows up with their software and says, I'm done with my software, and then it all magically fits together. Life isn't nearly that smooth. So if you have a large project that has software that's been divided up into modules or sections or something like that, and it's time to build the final product, there's an interesting question about how you actually make that happen. It'd be great if you could just show up with your software and they show up with their software and you just put it together and then magically like it all works together. But you know, if you have some dependencies, if you're assuming that they have some variables or some data that your software uses, that's great. But maybe they have dependencies on you. And then we don't compile stuff in Python. Python's an interpreted language, right? But most other languages like Java and stuff like that are compiled. So you have to compile the code, which means I take your source code, stuff that you can read, I process it, and I create a binary file. Great, now I got all these binary files, now I got to put all the binary files together into a single file. Things get complicated pretty quickly, and that's where the issue of build strings are show up. So, here's a picture of the last program that you wrote. You may not have realized it, but it actually had a whole bunch of different modules to it. Get inputs, that was sort of a big part, wasn't it? Calculate the age, print insurance status, print 2 versions of the social security number, print the full name, print the Medicaid name, print the street address, encrypt the social security number. You remember that part, right? Print the gender, print the parent's name, print the flip date of birth and age, and collect older and younger information if it was actually needed. Now, once again, these are only like a couple lines apiece, right? But if it was a bigger program, if it was a more complex program, each one of these could be a significant chunk of code and potentially a chunk of code developed by somebody else, right? Now, I would like you to create the Lakeland Hospital order entry system. Well, you've got to bring all these together, right? And you got to get all these to work together. And that's where things start to get a little bit, shall we say, weird. Software has to be usable. Well, that seems like something we can all hang our hats on, right? When a new developer joins your team, they have to know what kind of dependencies they have for it. In other words, I'm working on this code. Where do I get my inputs from? Am I going to ask the user for inputs? Am I going to receive the inputs? Are there a bunch of variables that are already set up to key values? You know, where's all this stuff coming from? Okay? By the way, I've written my code now. I'd like to test it. I don't need the whole operating system code to test it. I just need part of it. So what parts could I grab, put with my code, and then do my test? Right? So interesting questions like that. A whole bunch of things can be done with your code. Obviously, you can compile all of it. Once again, Python's interpreted, but other languages like Java and C and stuff like that get compiled. You could run just part of it. If I'm testing, I don't necessarily need the whole shooting match. I just need a portion of what's going on. You can package it up with and get it ready to deliver to the customer in the end, and then there's a whole bunch of other stuff that you can do. Okay? Version control system does you no good if you're not going to be sure that your code's going to be used correctly. You know, we've come up with this absolutely wonderful, fabulous scheme where we check code in and check code out, and we worry about resolving issues if 2 people are working on the same code and stuff like that. Okay, great. End of the day, this does us no good if we can't actually produce a product, a software product to deliver to our customers. Okay, good code has to be easy to use in addition to being easy to get. So we've got a wonderful, fabulous content management system where all our code lives, but that's not good enough because that's really our source code and what we want is a final product. All right. So welcome to the world of what we call build scripts. Okay. We have to do a lot more than just compiling our code, or in your case, just running it and getting it interpreted. Because we've got different modules and different relationships and a whole bunch of it gets complicated really quickly. The sequence in which you do stuff becomes important. And that's why we talk about building a project, building a software project. A project of any significant size needs a build script to be associated with. And by the way, I apologize, it doesn't actually need a build script. If you don't have a build script, what you need is a human being. And that human being has to be quite smart and has to know in what sequence, what steps need to be done. You can always go to that person and say, hey, we need to build a software project, and that person will sit down and start to do the right things in the right order, using long, potentially complicated commands. Rock and roll, that's fantastic. But assuming you don't have that human being sitting around just to do that one thing, you're going to need a script. Okay? Building a project involves following steps and maybe even more. Compiling the source files into binary files. Once again, that's more of a Java C thing. Okay? Finding the dependencies. Remember, in your homework problem, you had a module, so to speak, that got all the inputs, right? Well, all the other modules use those inputs, right? To do things like calculating the date of birth, how old they were, doing the encryption of the social security number. They all used inputs they got from that input module. So that's an example of dependencies. And then finally, packaging up the product. So after I've compiled things and gotten everything into binary, I want to scoop it all together and basically produce one output. And of course, as always, there's more things that get done. So, this is your homework. Would it be fair to say that there was a number of dependencies? Okay. Now we know the mother of all dependencies comes from what? The inputs, right? Because you got the inputs, and then what did you do with the inputs? Stuff. You use that data, right? Okay, so we're all cool with that. So we can see all the arrows going to those. Now, what do we got going on here? One was we encrypted the social security number, remember? So we used an input, got the social security number, we encrypted it, and then we printed it, right? So there's like a double dependency going on there. Any other double dependencies? Yeah, there are. So you got inputs, you figured out whether or not you had older or younger information that you had to collect, and if you did, you would then go ahead and print the parent's name. Alright? That's a little extra code you had to throw in there. If I got this stuff, then I have to remember to print it, stuff like that. Whoosh. So, you know, I don't know if you realized it, but your last homework was a mess. As far as dependencies go, right? Now, you might not have thought of it at the time because it was running through your mind. Okay, I got to do this stuff, I did that, so I have to do this, That's fine, not wrong with that whatsoever. Man, you get to a big software project, those dependencies start to become a bit of a monster, right? This can easily get out of hand. I mean, this is just your simple, trivial toy homework project. Get to a big program, man, those dependencies can be huge. You know, why isn't it compiling? Oh wait, I need something from that other module. And it goes like that. Okay. So clearly, even at a simple level, there's some issues here. So we've got to come up with a way to solve this. So the way we build a project is we take your source files, we maybe take the compiled binary files, we take any additional scripting sort of files you have, we throw them into a gigantic machine that processes all of it, and what comes out the other end, with a little luck, finger crossed, toe crossed, is a final product that we can actually deliver to the customer. Okay? Now, what's interesting about this is that this is the most boring job in the world. And the reason is because it's exactly the same every time you do it. It's long, it's complicated, what sequence you do things in is very important. Flags and conditions and includes and all sorts of garbage like that is vitally important, but it is extraordinarily boring. And it's also very, very easy to do wrong. Oops, I forgot to include that one file, so that nothing works. So this is ripe for automation. If you can do it right once, if you can capture that in your build script, you're good for the rest of the time. Okay? Now, most large-scale development projects probably have one person who is in charge of the build. And their job, arguably, is designed to manage the build script file. And the reason is because, especially with a large project, you're going to have constant changes. Here we go. Constant changes according to your code. You'll take a large piece of code and break it up into multiple pieces. You'll realize that there's another user story that you have to do, so you'll create a brand new piece of code. Thus, you'll have to update your build script to account for that new code, and so it goes. So, I'd like to introduce you to Ant. Now, arguably, in this class, we don't really care that much about Ant. Ant is actually a build script tool for Java. But as you go out into the real world, there's a good chance you're going to bump into Ant or one of the thousands of other programs that are very much like Ant. We'll just use Ant as our example case in this particular file. Okay? Apache Ant is a tool. It's a build tool for Java. It compiles, it creates, and then it also deletes directories and even package files for you. So it does a lot of behind-the-scenes housekeeping, or it has the possibility of doing that if you ask it to do. It's a pretty sweet program. Lots and lots of development projects using it. Ant uses the concept of a build script to accomplish all this. In other words, you tell Ant what you would like it to do, and it will do it for you. Okay? The build scripts are written in what's called XML. If you've never seen XML, XML is so it's a command language. It's a scripting language. It's designed to be a human readable sort of programming language at a high level for different applications. So XML has its own structure, its own format, and its own syntax. But good news for you, human being, you can actually read XML. Okay? Build scripts tell Ant what to do when you need to build your program. So for your particular program, you will have a unique Ant script, and it will take care of pulling together all this like that. So how does this all work? Okay. So in Ant, for your particular project, you will create one build file. That'll be the master build file that says, here's how you put my project together. Homework number 1. The file is called build script. More often than not, it's called build.xml, and it contains all the steps that are going to be needed to pull the different pieces of code together that together make up your particular project. What's going to be needed to build your project is broken up into steps. Those steps are called targets in the vocabulary of Ant. Each target can have more than one task. We've got targets, and we've got tasks. And to build the project, you just run Ant with your build file. Run Ant, give it your build file, and then Ant runs off and does all the magical things that you need it to do, and poof, at the end, you get your final file. Or you get a screen full of error messages because something has gone horribly, terribly wrong, which does happen. Projects, properties, targets, and tasks. All right, so we're going to actually look at some Ant code now. So project, everything in your build file is part of a single project. So project name, homework 1, default, distribution. Okay, that's just going to be a little tag we're going to put in there. Properties. Ant properties are like constants. You know about constants, right? Setting a variable to a particular value that we can then use throughout the program. Constants for a script, they allow you to refer to values in the script, however you can change those values in a single place. Property, name, version, value, 1.0. So if we're doing a build for version 1.0 of our product, we can just use a property, basically set up a variable that says, hey, this is the 1.0 version, and then we can sprinkle that through. What did we talk about last time? We talked about, with our configuration management system, we could set up a tag for version 1.0. Right? Well, if we told Ant that we're building version 1.0, then when Ant talks to the configuration management system, the configuration management says, hey, what version of the code would you like to have? Now that we've set this property, Ant can say, oh, I'd like to have the 1.0 version, and do it things you have. Target. Target's just a set of work. So basically, it's stuff it's going to do. You can group different actions into a target. Target name compile depends on int, which is another target. Description compiles code. Now this is sort of an important thing. You can put descriptions throughout your build script. That just, once again, when you come back to it later on, it's going to be critical. You're going to go, wow, what does this code actually do? But if you have a description there, you're going to be able to remember what's going on.
So it's like components of
yes, that is going to right. And it actually becomes very important because when you run your build script, you're actually sort of producing documentation. So the more descriptions you put into your Ant code, the better, because you'll be able to remember what's going on. Okay. Task, and now tasks are at the lowest level of all this. A task in ANT is something that has to do with an actual specific command. This example, this task is make directory, and we're specifying the directory as being homework underscore 1. Okay. Now what's important is, although we're talking about one particular type of build script, which is ANT, it doesn't really matter what language you're using. A good build tool is critical for your project. Large scale projects need a good build tool. What a pain! Why bother with the build tool? It almost seems like you have to learn a whole other language. You sort of do, but there's a couple good reasons for doing this. It allows you to get things done faster. The alternative to using a build tool is to do it by hand. And arguably there are some people who are very quick and efficient at doing that sort of stuff like that. The problem is it's really easy to make a mistake. We're talking about long, complicated compile commands and linking commands and stuff like that. Yeah, you might be good at it, but as the project gets larger and larger, and also you might be the only person who's good at it. You take a day off from work, nobody's going to be able to do a build. That's not good. Right? The build is really for the team. It's not all about you. So in other words, if you want to be able to produce a version of the code, that's fantastic. But the other people on your team probably want to be able to produce a version of the code also. Right? And if they don't know all the specific commands to do it, they're going to be sort of out of luck is the problem. So if you have a build script and the build script is made available to everybody, well, fantastic. That means everybody can create versions of it. Okay? And probably the most important thing is the build script makes it impossible for a developer to leave a step out. You know, the number of commands you can have in a build script can be easily hundreds once you get to a large scale project, right? Very, very easy to forget something, to overlook something, to screw something up. Put it in a build script, you don't have to worry about it, it's going to take care of you, and you'll do it perfectly each and every time. So what makes a good build script? Good question. So a good script captures details that developers don't have to worry about. Basically, if you can figure out how to do it once, if you can put it into the build script, you're done with it. You don't have to remember all the details about how you compile or link or join together two pieces of code. The description information that you include in the tags can be used to automatically generate documentation, which is huge because everybody hates to do documentation. So basically put some additional information in your build script, and then every time you run the build script, it'll actually crank out the documentation that you can hand off potentially to customers. Build scripts compile the code in your project. It can handle target dependencies. In our particular case, the module int depends on the module compile, which depends on the module distribution.
What kind of documentation is it like giving us? Like how is this documentation?
I wonder if I have an example of that. I may or may not. It's basically going to show you what's included in your code, right? So what Ant's doing is pulling together the different modules, it's compiling them, and then it's getting them to play together nicely. So, say I have a piece of software that has optional components. If the customer paid me a lot of money, they get all the options, right? If the customer paid me a little bit of money, they get almost none of the options, right? So I can run my ANT build script depending on which option, which version of software the customer wanted. And the documentation that would pop out would tell me what modules were included in the software. So if they paid me a lot, which would be a nice hefty long list, and I would give that to the customer and say, here's the software, and oh, by the way, here's all the modules that you're getting. If it's a short little one, I'd say, I'd give it to them and say, look, this is what you're getting. By the way, let me show you what the long one looks like, what you're not getting, right? By give me more cash, I'll give you more stuff. Does that make sense?
Yes.
Okay, all right. The alternative is you go, what did I make for them? Okay, here, let me write it down on a piece of paper, and that's flawed, right? One of the other important things is making software is generally a messy process, right? So we compile things, we make binaries, we put those binaries together. We leave a lot of trash behind when we're compiling and generating a software product. So one of the great things about Ant is that it will clean up after you. So after it's compiled things, put things together, got you your final shiny, beautiful looking final product, it will actually go back and clean up all the trash, all the files and scripts and stuff that are laying around to get you taken care of so that you don't have to keep doing that yourself. Good build script is more than just compiling your code. Libraries, we haven't talked too much about libraries in this particular class, but you know that you write software. Fantastic. It turns out that out in the big, big world, there's a lot of other really smart people who have written software also. Things to do things like square roots and linear regressions and sorting and things like that. If you bring their libraries into your code, you can access their code. Fantastic. Well, ANT will take care of reaching out to the right list, grab the right library, and bring it into your code, so your code compiles when you do that. You can actually run the application also. How hard can it be to run a program? You just type the program in and run it. Well, sometimes it's really complex. If you have a real long, complex command line that goes with your program, that says, I want to run the program, here's the directory that has all of my data, here's the other directory that has where I want all of my output to go, and oh, by the way, here's a series of flags that indicate how I want the program to run. Oh, what a pain in the patooties. If you put that into ANT will take care of that for you every time. It'll just automatically run your program correct. Okay? And then you can also check out code, run tests, create archives, encrypt files, email. Oh yeah, you can email you when it's done. If you have a really big piece of software, building that software is going to take time. It's not just a matter of sitting in front of your laptop and waiting for it to complete. It could actually take quite some time. It takes a while to build Microsoft Windows. And that's not just happening now. That's probably easily a day or even 2 days worth of pulling together, compiling, and doing all sorts of stuff like that. So if you could have the system email you when it's all done, it's, hey, by the way, that task I was working on for like the better part of half a day, it's all done. Then you can come back, grab it, and do whatever you want with it.
Where it runs half a day of break.
And more often than not, that unfortunately is exactly what happens. If you automate it, it means you don't have to worry about it. Ain't nothing better than that, okay? So if you can get the whole concept of making your software product to be an automatic process, you don't have to spend any time thinking about that whatsoever, which is great because you've got a lot more important things to worry about, like how the city of Lakeland can deal with its zombie outbreak. All right? That's where the value is. Build script, there's not a lot of value. I mean, it's a critical tool, no question about that whatsoever. You need it in order to produce a successful product. But you really don't want to spend an awful lot of time on it because the customer's not buying your build script. They're buying what it actually produces. What to do with the build script? Well, it's interesting. We talked a little bit about the fact that the build script's written in XML and all that sort of stuff like that. It turns out your build script is code. It's code that you've written. Oh, okay. Well, we sort of know about that. What are we doing with the code that you write in Python? Oh, we're putting it into a configuration management tool. Fantastic! That's exactly what you should do with your build script. You know, your build script's going to change over time. You're going to delete things and add things and all that stuff like that. You'd really like to keep track of this version versus that version. Stick it in the configuration management tool. You check it in, you check it out when you're going to actually make changes to it. It's also available to everybody. If it's in the configuration management tool, people don't have to remember, hey, is this the right version of the build script to produce version 1 or version 2? And then screw that. Have them go to the repository, check out the version they need, and they'll be good to go. Tracks all changes and gets tagged when you do a release. I hadn't really thought about that. But we talked about tagging so we could actually create our software. That's great. Turns out you can also tag your build script and say, at this moment in time, what the build script contained was exactly what we needed to produce version 1.0 of our product. And that's exactly it. It also means that people can go back and run that version of the build script if they wanted to build version 1.0. All right, so what did we cover today? We talked about build scripts. We talked about the fact that build scripts have projects associated with them. Each one of those projects has properties and targets in it. Build scripts are critically important when you have a large-scale software project. There's a lot of tiny little details associated with creating a working version of software. And although it may be correct in your head today, you may not be able to keep it correct in your head tomorrow. And if you're not present and somebody wants to create a version of the software, it's critical that you have an automated tool available. We talked about the fact that ANT, Apache ANT, is a tool that folks use to do that in the world of Java. Okay? There's other ones for C and C++ and all that sort of stuff like that. It doesn't really matter. What matters is the concept of a build tool is a very, very powerful concept that will occupy a chunk of your life even when you ever go out and develop a job. Are there any questions at this point in time? Going once, going twice. All right. What are we going to talk about next time? Oh, hey, testing and also continuous integration. Integration that never, ever ends. Well, that should be pretty good. It's the never-ending story in your class. Fantastic. All right, when you come back, we're going to be talking about a little bit of Python. We're going to be talking about lists. And you should care about lists because lists are coincidentally a key part of homework 15 minutes, I'm going to say that that's 5 till 9 we'll come back, okay? 5 till 9.